And we're back. We're ready to do problems 16 through 20. 16 reads, a polynomial expression is shown below. Once simplified, what will be the coefficient on the x squared term in the answer? Well, I'm looking here and I see you're multiplying these and then you're subtracting that. So I'm going to, I know maybe your teacher said FOIL. I like to say distribute or double distribute because I have two things here. Your teacher might have also drawn a box or a window for this. 3x squared times 2x squared is 6x to the 4th. 3x squared times 5 is 15x squared. 4 times 2x squared is 8x squared. And 4 times 5 is 20. Now, if I'm subtracting all of those, I like to say that I'm going to distribute a -1. -1 times 10x cubed is negative 10x cubed. -1 times negative 3x squared is positive 3x squared. -1 times 4 is -4. Now, if I wanted the whole answer, I'd combine all like terms, but I only want to know what goes in front of the x squareds. And I look and I have 15x squareds plus 8x squareds. That makes 23x squareds plus 3 more, and that gives me 26. Next one, problem 17. Now this one's a biggie. If I look at problem 17, it reads, a phone company charges between 12 cents and 18 cents per long distance call made. This is shown by the system of inequalities below, where x represents the number of long distance calls made and y represents the total cost of the long distance phone call. Based on this information, which statement below is true? Okay, if a customer makes over 12 calls, she will pay 12 times $12.12 or 12 cents for long distance. Well, that's not what it says. It says that for each call, they'll call anywhere between 12 and 18 cents. This one says if a customer makes less than 18 calls, well, it doesn't say what they'll pay. It just says the price will be more than or equal to 12 cents per call, or less than or equal to 18 cents per call. Let's look at C. If a customer makes 100 calls, she will pay either $12 or $18. Well, no, it says she's within a range. So let's think. Let's look at D. I'm hoping D looks good. If a customer makes 200 calls, she will pay anywhere between $24 and $36 for long distance. $24 and $36 for long distance. That sounds good. Let's check. She makes 200 calls and she gets them at the cheapest rate at 12 cents a call. Multiply those, that would be $24. But if she makes 200 calls and gets them at the most expensive, which is 18 cents per call, that would be 36. So anything between there would be a good answer. Moving to 18, the price of a soda is S dollars, and the price of a bag of chips is C dollars. Alston bought 6 sodas. Oh, here we go. 6 sodas and 4 bags of chips and spent $17. Jamie bought 4 sodas plus and 8 bags of chips. He spent a total of $22. These facts are represented by these equations. Which statement is true about this system? Some of you may solve using matrix. Other people may solve using what's called elimination method, meaning I need either the S's or the C's to fall out. At a quick glance, I notice if I multiply this row by a -2, my C's would fall out because I would have a -8C and a positive 8C. So let's do that. I'll get -12S minus 8C equals -34. Bring over the other equation without changing a thing. Then combine or add straight down, and I'll get -8S cross out or zero out, equals negative 12. Divide by negative 8, and I'll get S equals $1.50. I know it's the price because of how they worded things up here. 6 sodas, so 6 at a cost of $1.50. Well, now that I have sodas, I better find how much the chips cost. I can go back to either equation. I'm going to choose the first one. 6 times $1.50 plus 4C equals 17. 6 times $1.50 is 9. Plus 4C equals 17. Subtract 9. 4C equals 8. Divide by 4. Chips, or C, equals $2. So let's go through our answers here. A soda costs more than a bag of chips. Let's check. $1.50 for soda. Chips, $2. No. A bag of chips costs twice as much as a soda. Well, $2 is not twice as much as that. Moving on. A soda costs 50 cents less than a bag of chips. Hey, that sounds good. Soda's $1.50. Chips are $2. That is definitely 50 cents less. Go to mark C. And moving on to 19. 19 reads, compound inequality is shown below. Compound just means I have two symbols here. What is the solution to this inequality? I'm going to write it again just so I have a little more space. If I'm solving it for x, x is located in the middle. So I want to get x by itself. So I'm going to subtract the 6. I need to do that on the left, in the middle, and on the right. I will get a negative 26 less than negative 2x less than 22. Again, my x is in the middle. I need to get rid of the times negative 2. So I will divide everybody by a negative 2. When I do that, I am dividing by a negative, so I will need to flip the inequality symbols. Negative 26 divided by negative 2 is 13. Greater than x, greater than negative 11. Now, this is a great answer. However, it's not listed here. I want you to know that typically, when you write something in compact form like this, they will have it reversed where the smallest number, negative 11 is the smallest one, is written first. They will flip the entire thing around, making B your answer. Last one I want to go over in this video is number 20. Looking for the least common multiple of these three. So the first thing I need to do is think of what is the least common multiple of 9, 15, and 5. What is the first number that all three of them divide into? Well, I can kind of look at my multiple choices and think it's either 45 or 3. Well, 45 is the only number that all three of those go into. And then I also need to make sure that I choose the greatest number on the exponents. So all three of these could go into it. If I look at the x's, I have a 2, a 3, and a 2. The biggest one is a 3. So it's looking like this, guys, my answer. Let's keep checking, though. A 3, a 4, a 3 for the y's. 4 is definitely the biggest. And z squared is definitely bigger than when they just had the first power. That concludes 16 to 20.